You ever play with a chatbot and wonder how it goes from, just okay, to a powerhouse like ChatGPT or Gemini? Well, it's not magic. It's all about the engineering behind the scenes. And today, we're going to pull back the curtain on the key concepts that make it all happen. So, what really is the secret sauce? What are those hidden upgrades that turn a basic large language model into a truly powerful, reliable AI system? That is the big question we're going to tackle right now. Okay, so look at this. On the left, you've got your basic model. You type in a prompt, you get a response back. Super simple. But on the right, that's a whole different beast. That's a production AI system. It's a full-blown ecosystem with all these interconnected parts, tools, memory, data, caching, all working together. We're about to break down exactly what those crucial building blocks are. First up, let's get into the absolute fundamentals. These are the core concepts that give an AI its awareness and, maybe more importantly, its ability to get its hands on the right information at the right time. Think about context engineering like this. You're giving a personal assistant a perfectly organized briefing packet before a big meeting. Seriously, the quality of that packet, the instructions, the past conversations, the reference documents, is often way more important than how you phrase your final request. Getting the context right is without a doubt the most critical first step. Now this is where the AI actually starts to do stuff in the real world. It's a process called tool calling. See, instead of just relying on whatever it was trained on, the AI realizes it needs current information. So it calls an external tool, like a weather API, to get live data. It's like giving your AI a phone or a calculator. It can suddenly interact with the world and answer questions about what's happening right now. Okay, so you've got all these different models and all these different tools. How do you get them to talk to each other without creating a complete tangled mess of custom code? Well, that's where something called the Model Context Protocol, or MCP, comes in. Just think of it as a universal adapter. Instead of building a new plug for every single combination, MCP lets any tool plug into any model, nice and easy. This is how you build systems that can actually scale. All right, so with that foundation in place, let's get to the really fun part, making AIs work together and, actually remember what they've learned. Agent-to-agent communication, or A2A, is basically like creating a secure, private group chat for a team of specialized AI agents. You could have one agent that's a brilliant researcher, another that's a master strategist, and a third one that just executes the plan. A2A is the framework that lets them all collaborate seamlessly to tackle really complex problems. And just like us, these AI agents need memory to do their jobs well. You can kind of break it down just like the human brain. You've got short-term or working memory for the task at hand, what it's focused on right now, and then there's a long-term memory, which is like a huge structured library of information it can search through whenever it needs to. Getting that balance right is absolutely key for an efficient AI. Now, let's talk about making our AI system not just smart, but also fast, efficient, and, affordable. These optimizations are the kind of thing that can make or break an application when you're dealing with lots of users. So imagine you ask a librarian for some info. The very first time, they have to go search through the entire library, right? That takes time, and in the world of computing, that time and effort costs money. As you can see, it's not a lot, but it adds up. But what if you ask a very similar question a little later? Well, that's where semantic caching comes in. The system is smart enough to recognize, hey, I've seen this before, and just gives you the answer it already found. And look at that difference. The cost and time basically disappear. It's like the librarian just remembers the answer off the top of their head. It makes the whole experience feel so much faster for the user. Let's stick with that library analogy for a second. Let's say the AI finds a 500-page book to answer your question. Are you going to make it read the whole thing? No way! Contextual compression is like a magic highlighting tool. It scans the book and pulls out only the most relevant sentences or paragraphs. This saves a ton of time, cuts down on noise, and, you guessed it, lowers the cost. Okay, so here's a super common problem. The system goes out and finds a few documents to answer a question. But look, the most important one, the highly relevant one, is buried at the bottom of the list. This can totally confuse the AI and lead to some pretty weak answers. And here's the fix. It's called re-ranking. It's like a smart editor that just reorganizes the list, putting the most critical information right at the top, where the AI will see it first. It seems like such a simple step, but it dramatically improves the quality of the final answer. All right, finally, let's cover the concepts that are just non-negotiable for building robust AI systems that can handle real-world traffic and all the messiness that comes with it.
To find the best information, you really need the best search team. So, semantic search is like your brilliant researcher. It understands ideas and concepts. Keyword search is like your meticulous archivist. It's amazing at finding exact names and phrases. Hybrid retrieval puts them both on the same team, giving you the best of both worlds and the most reliable results possible.
Look, when you've got thousands of users, you can't just throw your most powerful and most expensive AI model at every single question. That'd be insane. An inference gateway acts like a smart traffic dispatcher. It looks at a question, decides if it's easy or hard, and sends it to the right model for the job. Simple questions go to a fast, cheap model, saving the big guns for the really tough problems. This is absolutely critical for managing costs at scale.
So, we've covered a ton of ground here, but what this all really adds up to is a fundamental shift in how we think. It's about moving from just using an AI to truly engineering an AI system.
And this right here is the heart of it. It's not about finding one magic prompt or one perfect model. It's about mastering all these different building blocks, context, tools, memory, optimization, and putting them together to build something that's truly robust, scalable, and effective.
So I'll just leave you with his one question. Now that you've seen a little of what goes on behind the curtain, are you still thinking like a user who just types in prompts? Or are you starting to think like an architect who designs the entire system from the ground up? Because that shift in perspective, that's what modern AI engineering is all about. Thanks for tuning in.